Yes, students, good evening. Then today is the second class on PYQs. Yesterday we did, okay. Today also there are there. And these are only the questions from 2022 alone. So think that every year how many questions are there from each chapter. 2022 only we have done. 2023 is there, 2024 is there. So many PYQs are there that you have to do. Okay. I am taking at the moment for you 2022 and all the chapters we will do like this. Okay, so that you are comfortable, you know that what type of questions are actually asked in JEE. Okay, so let's start. Let's see how these questions are. Right. So see now, two capacitors each having capacitance 40 microfarad are connected in series. The space between one of the capacitor is filled with dielectric constant K, such that equivalent capacitance of system become 24 microfarad. The value of K is. What they are saying? Two capacitors, each of capacitance 40. Each of capacitance 40. Okay. So this is important. Each of capacitance 40 are connected in series. Okay. Let's make them series first. This is capacitor 1 and this is another capacitor. Okay. This is 40 and this is also 40. Right. Now, they say that connected in series, we have done that. The space between one of the capacitors is filled with dielectric constant K. Alright. So let's fill it. Okay. So we are filling it now. This is filled. So one of the capacitor we filled with K equal to 5. Okay. No, where is 5? K only. Okay. K. Such that equivalent capacitance of the system becomes 24 microfarad. Now, earlier if we see, this is 40, this is also 40. And what is the C net? We know that whenever series connection is there, C net we used to write as what? C1 C2 by C1 plus C2. This is our method of writing the net capacitance. So this is also 40, that is also 40. So let's see first. 40 into 40 by 40 plus 40. Right. So 40 into 40 by 80. So this is 2 and eventually 40 by 2 means 20. Okay. So earlier, this is C net initially. This is the initial C net. Okay, 20. But he says if you are going to put K over here, then resultant becomes 24. Okay. So once you are putting K over here, what is the capacitance of this capacitor has become? K times. So now this has become 40K. And this is still 40. So now what is the new capacitance? We will see. So new capacitance we will say C net final. Again formula is same, C1 C2 by C1 plus C2. No change in that because it's a series connection. So what you will do? 40K into 40 by 40K plus 40. And C net value is given how much? 24 it is. Okay, put here 24 also. So this is 24. Okay, let's try and solve this one first. 40K into 40 I am writing as it is. No change in that. But in denominator I am taking 40 common. 40 is common. So 40 if you take common, then you have K plus 1. 40 and 40 cancel. Right, now what we can do? We can multiply. Okay, so what it is? 24K plus 24 equal to 40K. 24K plus 24 equal to 40K. Now what we can do? 24K we can take that side. So 24 equal to 40 minus 24, that is 16. So 16K. So K value is what? 24 by 16. 24 by 16 means 3 by 2. K value 3 by 2. Okay. Do we have anything option like that? Yes, we have. A option is there. Okay. So it is 3 by 2. Right? Okay. Is it clear? Any doubt in this one? Come on, come on, come on. Say something. Any doubt is there in this question? Okay. Right. Kishore, you also say what is there? Okay, good. So no problem, no doubt. Okay, let's go ahead then. Okay, these notes I'll be posting to you. If you are not able to note also, don't worry. This will be coming to you. From there you can note. So don't worry about the notes as such. We could not copy it. Don't worry. Okay. All right. But where I'll be giving these notes? It will be in the app only. Classes also will be recorded. It will be going in the app, as well as these notes also will be going in the app only. Okay. All right. Let's move ahead. Next question. So two identical thin metal plates has charges Q1 and Q2. Two identical thin metal plates has charge Q1 and Q2 respectively, such that Q1 is greater than Q2. All right. The plates were brought close to each other to form a parallel plate capacitor of capacitance C. Okay, so what they are doing is two different plates are there. You have given charge. One charge is Q1, another one charge is Q2. Now you are bringing close to each other and you are saying that its capacitance is C. The potential difference between them is. Okay, so this is one plate. You are saying charge on this one is Q1 and this is another plate. Charge on this is Q2. Q1 is greater than Q2 given. What is going to happen? He says you are making capacitor out of this. Now in capacitor what we have learned? We have learned that the charges on the two plates, particularly inside, will be equal and opposite. Here positive charge, here will be negative charge. But here Q1 and Q2 are given. Now how to find? We have learned it. What we learned, if you remember, if there are two plates like this, you are bringing them close to each other, then outside, here and here, the charges will be half of the total. That means here charge will be Q1 plus Q2 by 2. And here also Q1 plus Q2 by 2. No doubt about that. Okay, this gets arranged. Why this happened like this? Because of induction. Because of induction of this on this one. Now, how much charge is left over here? Total charge is Q1. It will remain Q1 because nobody is giving the charge, nobody is taking the charge. So it will remain Q1. Here is Q1 plus Q2 by 2. Then here is how much? Here will be Q1 minus Q2 by 2. Now add both this and this you add, it will come Q1 only. Because Q2 by 2 and Q2 by 2 will get cancelled. Q1 by 2 plus Q1 by 2 is Q1. Same way here how much? Here charge will come Q2 minus Q1 by 2. Again add Q1 by 2 will cancel. Q2 by 2 plus Q2 by 2. But this charge Q2 minus Q1 by 2 I will be writing as what? Minus Q1 minus Q2 by 2. This one I can write like this. Why? Because that is only we have learned in capacitor that this charge and this charge will be exactly equal. One will be positive, other one will be negative. So what is the charge on the capacitor here? Q1 minus Q2 by 2. This is the charge on capacitor. If you remember that in capacitor I told you the charge on inner side of the positive plate is the charge on capacitor. Q1 minus Q2 by 2. So what he is asking now, V value, that is potential difference. So V is what? Charge on capacitor by capacitance. How much is charge on capacitor? Q1 minus Q2 by 2. So Q1 minus Q2 by 2 by C. So our answer is Q1 minus Q2 by 2C. This is the potential difference between these two plates. That's all. Over. So C, Any option is there like this? Q1 minus Q2 by 2C, here it is. So option is C. Tell me, is it clear to both of you? Okay, no problem. Kishore might have not attended this. Kishore, you have all this in app. You have to first download the app, sign in, and then you can access all this. This is an electrostatics I have taught. Okay? Alright. Let's move to the next question now. Okay. Next question is this. The two parallel plate capacitors of capacity C and 3C are connected in parallel combination and charged to potential difference 18 volt. Okay. Now there is no options you see. There are no options here. So this is actually integer type question or numerical question in JEE, in which you have to write the answer. No options will be given. Okay. So these types of questions are also asked in JEE. Okay, let's see. So two parallel plate capacitors of capacity C and 3C are connected in parallel. Okay. So if we say solution over here and we say this is C and another one is 3C. Okay, they are connected in parallel. Then what? And charge to potential difference 18 volt. Okay, you have connected them with a battery of 18 volt. All right. Fine. Now what? The battery is then disconnected. All right. And the space between the place of capacitor of capacity C is completely filled with a material of dielectric constant 9. Okay. So here is this C. Okay. Potential difference is 18 volt here. Another one is 3C. This is 3C. And here also potential difference is 18 volt. Now what you have done is you have inserted one dielectric here. Okay. Now this dielectric constant of this one is 9. K is 9. Okay. K value is 9. So suddenly what happened? If you are inserting this dielectric over here, suddenly its capacitance becomes 9C. If you are inserting a dielectric, what happens to capacitance? Capacitance becomes K times. So what is K? 9. So its capacity become 9C. Earlier how much it was? C only. Now it became 9C. So what will happen? Charge will flow. Common potential will come because it's connected like this. So they will reach to common potential, right? But okay, here anything we have to do? No, nothing we have to do. From here, we have shifted already to here. Now what we have to do? We have to find common potential. That's what he's asking, right? Final potential difference across the combination. So common potential's formula do we remember? So yes, we remember. What is the formula? Total charge by total capacitance. Total charge by total capacitance. Okay, now how much is total charge? Now total charge means what charge is here. Because when you are inserting dielectric, you are not giving any charge. So whatever charge is here, same will be the charge here. So here also 18 volt is coming. Here also 18 volt is coming. So how much is charge on this one? Charge on this one we will say Q1, which is equal to 18 C. CV, no. CV, Q equal to CV. So 18 volt into capacitance. Same way here, 18 volt into 3, 54. So Q2 is 54C. So what is this total charge? Q1 plus Q2. Q1 plus Q2 means 54 plus 82, or sorry, 54 plus 18. So 54 plus 18 is 72. Okay. So total charge is 72C. By total capacitance. Now here total capacitance was 3C plus C, 4C. But is he asking this? He is asking this. Here how much capacitance? 9C. Here 3C. 9C plus 3C. 12C. So 12C. C and C gets cancelled. Answer is 6. 6 volt. Because of insertion of this, the common potential from 18 volt drops to 6 volt. Okay, that's the answer. Answer is 6 volt. Our answer here will be writing 6. Is it clear? Is it clear, students? Good. Okay. Right. So let's move on to the next one now. Right. What is this now? A composite parallel plate capacitor is made up of two dielectric materials. You can see that this is the capacitor he is talking. Composite parallel plate capacitor is made up of two dielectric materials with different thickness T1 and T2. This is thickness 0.5 mm and 1 mm. As shown in figure, the two dielectric materials are separated by conducting foil F. This is foil. This one. Okay. These two capacitors are separated by a conducting foil F. The voltage of conducting foil is. What is the voltage of this? Okay. Now what I am going to do is I am going to redraw that. Why? Because certain times what happens when we are making these capacitors vertical, we don't understand, we don't imagine, we are not able, don't know, we are not able to imagine. So make them in a proper way in which we do understand them. So how, what I am trying to say? I am trying to say make the capacitors like this. Okay, this is better for us. So two capacitors are given like this. Okay, and then they are connected across 100 volt battery. That's it. This is easy for us to understand. Now what is there? He says this is 0.5 mm. That's gap between them. Okay, this is 0.5 mm. Okay, and here dielectric constant 3 is there. Okay, then another one is 1 mm. So here gap is 1 mm. I have intentionally made it bigger. This is 1 mm. Okay, and here dielectric constant is 4. So here itself I am writing. Okay, now then what? Anything else is there? Right. Now there is this foil. This foil we are calling as F. This one, this pink one. I'm making it pink. This is F. Okay. Now how much is potential here we have to find. How much is potential here we have to find. Now see, battery is here 100 volt. What I am assuming, suppose here is 0 volt. If here is 0 volt, that means here is 100 volt. Okay, this is 0, so that means here also 0 volt. And here is 100 volt, remember. Just leave it for the time being. Okay, this 0 and 100, just leave it. Now, normally you solve. Now, two capacitors are there. Let's find out their capacitance first. Okay, so this is C1, this is C2. C1, which is C1? This is C1. And this is C2. Okay, what is C1? Now, C1 we will say, what is the formula? K epsilon naught A by D. K epsilon naught A by D. What is K here? 3. So 3 epsilon naught A by D value. Now D value is how much here? 0.5 mm. 0.5 mm. Okay. Don't convert it in meters. Okay, unnecessarily 10 to the power minus 3 will come. Let it be in millimeter only. Okay, don't convert. So 0.5. 0.5 shall I write 1 by 2? Yes. So 1 by 2. So 1 by 2, 2 will go at the top. So it will become 6 epsilon naught A. That's C1. Okay. C2. Let's find C2. C2 is again K. What is K here? 4. So 4 epsilon naught A by 1. So this is 6 epsilon naught A. This is 4 epsilon naught A. So for the time being, let's assume this epsilon naught A is actually equal to C. So C1 is what? 6C and C2 is 4C. Perfect. How are they connected? They are connected in series. They are connected in series. Understandable? Fine. Now how potential drop we measure? One method I told you. Inversely proportional to capacitance. Right? That I told you. Two methods I told you. So which method I am going to do? I am going to first find the net capacitance and then we are going to see how much potential is dropped. Okay. So what is net capacitance here? So net capacitance in series connection, how to find? C1 C2 by C1 plus C2. What else? Okay. So 4C into 6C by 10C. I added them. Okay. This cancelled. Okay. 24 by 10, that is 2.4C. Done. Net capacitance we got. Now what we can get? Charge. Charge is Q equal to CV. So net charge C net into V, that is 2.4C into 100. That means 240C. Okay. Now being in series means same charge will be on this also, same charge on this also. So how much is potential drop across this? This is C1. C1 means 6C. So V1 is how much? Just see that. How much potential is going to drop over here? That is what we have to see. What is V1? Okay. So V1 is Q net, this Q, by C1. So 240C by 6C. How much is coming? 40. So potential drop across this one is what? 40. How much is here? 100. 40 drops. Then how much will be here? 60. Able to understand? See again. I'll make it over here. Okay, see. I'm making slightly bigger. Yeah, this is C1. Okay, here potential is 100 volt. How much is dropped? 40. Here is dropped 40. So here is how much? 60. The 100 minus 60 only 40, right? So what is the potential on this plate? 60. So our answer is what? 60 volt. Right? It took us time. Time in solving. The tough question. Yes. It is a tough question. But is this clear to you? Anywhere doubt is there, ask me. Anywhere you felt like it is, you did not understand, please ask. Yes, students. Any problem, any doubt? Okay. Sure. I'll explain you one more time. No problem. Now what I'll do is, I'll just remove this from here. Now, if you understood this one, I can remove this. Or I'll make it a little smaller. That I can make. Yes, be a little smaller. Too small is visible to you or not? Okay. Keep it here in the side. Okay, I got a little space. Now why required space? I want to redraw that. This one I'll redraw, I'll make little bigger so that I can explain you one more time in a better way. Okay. So, fine. Okay, I want to redraw. So, here it is. Right. So, let's redraw that. Okay. So, two capacitors. These are the capacitors I am redrawing. So, capacitor number 1. This is capacitor number 1. Okay. Capacitor number 2. And it's connected with a battery of 100 volt. Now, this 100 volt means is potential difference is 100 volt. Right? So, what we are saying? Here we took 0 volt. So, here automatically comes 100. Here, this is connecting wires. So, connecting wires, potential will remain same in them. Okay. So, here 0. So, here also 0 volt is there. Same way here is 100. So, here is also 100. Okay. Now, this is C1. Where is C1? This is C1. And this is C2. Okay. So, we found C1 value. We said that C1 is what? K epsilon naught A by D. What is K? K is 3. K here is 3. Here is K3 and other place K is 4. Okay, this is 0.5 mm and this is 1 m. Okay, so what we have done, C1 is K epsilon naught A by D. So how much is the 0.5 mm? 0.5 means 1 by 2. 1 by 2. So 2 went up, becomes 6 epsilon naught A. Okay, C2, 4 epsilon naught A by D, which is 1 mm. And now epsilon naught A I assumed as C. Why? Because again and again I have to write epsilon naught A everywhere. So it's better to write C in place of that. It is smaller. Okay. So epsilon naught A is C. Now I calculated what is the net capacitance. Net capacitance C1 C2 by C1 plus C2. We kept the value 4C, 6C and C1 plus C2 10C. It becomes 2.4C. So what is the net charge then? C net into V. That is 2.4C into 100. 100? This is 100. Q equal to CV. So 240C is the net charge. Now question is how much potential is drop on this? The potential drop will be what? Charge by capacitance. Charge by its capacitance. On this one will be charge by its capacitance. So here we found how much is the charge, how much is the potential. Okay. So C1, V1. V1 equal to Q by C1. What is V? Sorry, what is Q? 240C. And what is C1? 6C. So what's coming? 40. So that means potential drop here is 40. Here is 100. Here dropped 40. So how much is here now? 60. So how much is dropped on this capacitor? If suppose they ask how much is dropped on this capacitor, 60, because here is 60, here is 0. So total potential drop will be 60. We can calculate also. If suppose I do here V2, V2 equal to Q by C2, if we do, it will come 60 only. Check. Q is what? 240C. C2 is what? 4C. See, 60 is coming. So here potential drop is 40, here is 60. But he is asking how much is potential on this plate. How to find? This potential minus this potential is potential. Okay. Is this clear? Is it clear, students? Okay. Right. Let's move. Move to the next one now. Okay. See now. 1, 2, 3, 4, 5, 6 capacitors it has given, and he is asking what is the net capacitance between A and B. Okay. Net capacitance between A and B. But in between these connecting wires are connected. What is the meaning of that? I'll show you. Okay. What I'll do is this CAB, for the time being, I'll just shift it upwards. Upwards means above I'll write. Here I'll write find CAB. Okay. Now I am changing this diagram. In fact, I'm just connecting it with a battery. Okay. I connected with the battery, let's say 100 volt. It's not given in the question. Can I do that? Whenever they say find capacitance between A and B, that means there is a battery connected between A and B. That is the meaning of that. So why I am connecting? Without that I can solve? I can solve. But for you I am doing it because in this one, the concept which is used, that kind of concept we are going to learn in next chapter, current electricity. Okay. So just to be easily that you can understand that I am using it. Okay. So now right now what we did in the previous question, I told you that take here 0 volt. Here also you do that. Here is 100. Do that. Okay. So 0 volt means here 0. 0 volt. And here 100 volt. Okay. Perfect. Now here 100 means here also 100. Connecting wire only. Here also 100. But here this connecting wire is going. So here also 100 it will be then. Absolutely. If this is 100, here also 100 volt is there. I should write it with a different color. Okay. This is also 100. Done. That's okay. Okay. Now, what more we can do? Now, suppose that here, I don't know how much is potential here, but let's say this end I am assuming as P. So here potential is P, whatever it is, P. So here also potential will be same only, no? Answer is yes. Here also potential will be P. If connecting wire is there, connecting wire means is the potential at the two ends will become same. Remember always. Okay. So here also P now, this is also connecting wire, that means here is also potential will be P. Done. Right. Can we solve it right now? No, we have to redraw it now. We will be redrawing it. Okay, let's see now. This is 100 volt, no? This is A actually. Let's say A. This is A. And everything else is, this is B. Okay. So now I am going to redraw it. See now how to redraw. Okay. A point. This is A point. Okay. So there is capacitor between A and P. There is a capacitor between A and P. And okay. Done. Which one I have drawn? This one. 1. Then there is a capacitor between A and P. One more time. Okay. Okay. This is 2. This is 1. This is 2. These two I have done. Then let's go to third. So again between A and P. Again between A and P. Okay, fine, no problem. We'll make one more. Third. Okay, now this is P and this is P. P and P. But if this is P and this is P, here potential and here potential is same, then this charge will not go through this, no? We have studied. What we have studied? The charge will go only when there is a potential difference, right? The charge flow from higher potential to lower potential. But here there is no potential difference. This is P, this is also P. So there is no charge. So these are actually useless. These two capacitors are useless capacitors. Then after that, P and B1 capacitor is there. Okay, P and B1 capacitor is there. So this is your fifth one. These are useless. He is asking net capacitance between A and B now. Now see what type of connection is there. These three are parallel. So if these three are parallel, this is how much? 8, 8, no? So these three are parallel. So 8 plus 8 plus 8. In parallel connection, C equal to C1 plus C2 plus C3. 8 plus 8 plus 8. So I am writing C now. This is A, this is P. So how much is this? 24 microfarad. 8 plus 8 plus 8. Then between P and B1 is also 8 microfarad. Now, how they are connected? Series. This is series connection. So, CAB, how to find? C1 C2 by C1 plus C2. 24 into 8 by 24 plus 8. 24 into 8 by 24 plus 8. So, 24 into 8 by 32. 8 4 ja, and then 4 6 ja. Our answer is 6 microfarad. 6 microfarad. Important concept. If there is no potential difference, then charge will not flow through the capacitor. Then how charge is going to flow? Through the wire. Through the wire it's flowing. Okay, it will go from here to here. And then it will go through this battery, or rather this capacitor. But it will not pass through these capacitor because across them potential difference is 0. Is it clear? Come on, give me response, both of you. Yeah. Okay, good. Right. So let's move to the next now. Let's see what this is. Now see that this is very interesting question. A parallel plate capacitor is made up of stairs-like structure with plate area A of each stair, and that is connected with a wire of length B. The capacitance of arrangement is X by 15 epsilon naught A by B. The value of X is. Again a numerical type question. Okay. Now this capacitor is given. What you can say in this one? How many capacitors are there? 3. 3 capacitors. Now look at how I am seeing this question. Try and look at, because you also have to make your visibility, rather imagination in that. Okay. So see now, this is first between these two plates. Okay. Then this is second. This is second one. And then this is third one. 1, 2, 3. How are they connected? Parallel. Why? Because this is single plate only, which you have turned and made like this. This is a single plate. And this is also single plate. Okay. So what we have to do, if I say that this is C1, this is C2 and this is C3, I have to write first of all what is the C1 value, C2 value, C3 value. And then since they are connected parallelly, what I will do? C1 plus C2 plus C3. As simple as that. Okay. But it's not that simple, right? C1 we have to write first. Just see now. C1 is what? C1. What is the area of the plate? A. What is the separation between the plates? B. So C1 is epsilon naught A by B. See? Simple. Okay. C2. How much is the gap in this one now? B, B, B. How much is the gap? B, B, B. 3B is the gap. So C2 is what? Epsilon naught A by 3B. Okay. Now C3 you see. B, 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 B. How many B's are there? 5. So C3 is epsilon naught A by 5. Then C net is what? C1 plus C2 plus C3. C net C1 plus C2 plus C3. Done? Now anything is common in all of them? Yeah, epsilon naught A by B is common. Take epsilon naught A by B common. Epsilon naught A by B. So here is 1, here is 1 by 3, here is 1 by 5. Okay, so then epsilon naught A by B, its LCM will take, how much will come? 15. Okay, so here 15, here is 5, and then here is 3. So 15 plus 5 is 20, 20 plus 3 is 23, right? So epsilon naught A by B, 23 by 15. So check what is X value? 23. Compare. 23. Is it clear? Any doubt is there? Please ask. Alright. So going good. So that means it looks like yes, you have learned capacitance well. Okay. Right. Let's see what this is now. A capacitor C1 is charged to a potential of 30 volt. Okay. This is C1. This is charged to potential of 30 volt. Okay. Now it is connected to uncharged capacitor C2. Uncharged capacitor C2. At equilibrium, charge on C2 is easy question for us, right? This is how much potential given? 30. This is charged to 30 volt. And this is, its potential is 0 because it's uncharged. Connected them. What will happen? Common potential will come. We know that. So V common. And what is V common? Total charge by total capacitance. Total charge by total capacitance. What is total charge? What is charge here? The Q1. Q1 is how much? 150. Multiply. Okay. 5 into 30. 150 microcoulomb. And here what is the charge? 0. Okay. So total charge is this 150 microcoulomb only. So 150. Okay. By total capacitance is how much? C1 plus C2, that is 10 plus 5. 10 plus 5, that is 15. So what is the V common? V common is coming 10 volt. This is V common. Now what is the question? What is the charge on C2? C2. Okay, so what is Q2? Q2 is C2 into V common. What else? What is C2? C2 is 10 microfarad into 10. What is the answer? 100 microcoulombs. That's all. Over. Finished. Is it clear, students? I think some just check that question is visible to you, or it is getting slightly cut. Now it's okay, right? Students, now is it better, right? Yes, able to see the question properly. As earlier, you were not able to see the question. Yeah. Okay. So I hope the question is clear to you as well. Okay. Shall we go ahead? Say yes or no. Okay. Okay, let's go ahead. All right. Okay, let's see what this is now. A parallel plate capacitor with width 4 centimeter, length 8 centimeter, and separation between the plates 4 mm is connected to a battery of 20 volt a dielectric slab of K equal to 5 having length 1 centimeter, width 4 centimeter, thickness 4 mm is inserted between the plates, the electrostatic energy of the system. Read it twice or thrice, okay, because it's the language is such that difficult to understand. I'll explain you, there is no doubt, but you should understand. No, ultimately you have to solve it in the exam, not me. Parallel plate capacitor is there. Okay, plate size is given. Width 4 centimeter, length 8 centimeter, and separation between the plates is 4 mm. So what I will do is, first of all, I'll try to make, okay, I'll try and see if I can make it correctly, correct diagram, or I'm not able to. Let me check if I am. I don't think. In a different way I have to make. Okay, fine. See. Okay, this is the plate. Okay, one more I'll make, or just we'll copy this one. Okay, this is parallel plate capacitor for us. Okay, now in this one given to you that its width is 4 centimeter. What is width? Width is here. This is 4 centimeter. Right. Then length is 8. This is length. Okay, this is 8 centimeter. This is 4 centimeter. Then they say that the separation between the plates is 4 mm. So okay, fine. This is 4 mm. Okay, now what more? And is connected to a battery of 20 volt. That's okay. We'll connect this with a battery of 20 volt. Connected. Okay, then a dielectric slab of K equal to 5 having length 1 centimeter. This is 8 centimeter length. Only 1 centimeter length. Width is 4, okay, and thickness 4 mm. Okay, fine. So it means is you are putting a dielectric where only this much. Only this much here. Okay, like this. Okay. And above also, like this is fully filled. Here is your dielectric. Okay, this is the dielectric. I can fill it also if you want. You can fill it also so that it's visible to you in a clear way. Okay, this is your dielectric. Only this much area. Remaining all is vacuum only. Right, it's like this. Okay, then what they want is inserted between the plates the electrostatic energy of the systems. So now what has happened now? Because you inserted this dielectric, now this is a different capacitor, this much, and this is a different capacitor. If this is different capacitor, then what type of connection? Series or parallel? Parallel. Why? Because these two plates have how much potential difference? 20. So whatever the potential difference is, 20 only, no? Where it is? 20 volt. So here also 20 volt potential difference, here also 20 volt potential difference. This is a parallel connection. So now two capacitors are there, C1 and C2. Now C1 is which one? This is our first one. This is first, this is second. What is C1? We'll find. Okay. What is C1? Say K epsilon naught A by B. What is K? K is 5. Epsilon naught. Now A is what? What is A? A means this area. This is 4. And he said this is 1. Length is 1 he has given, no? Length is 1. See, and width is 4. So what is its area? 4 into 1, 4 centimeters square. 4 centimeters square. We can convert this into meter. We can do that, but at the moment let's write. After that we'll do. D is what? 4 mm. This is your C1. Then C2? Okay, C2 also. But C2 there is no dielectric. It's epsilon naught. Now area. Okay, now total length was 8. Out of that 1 is gone. How much is remaining? 7. 7 into 4, that means 28. The 28 centimeters square by 4 mm. Perfect. Now we are saying that first we have to find what is the net capacitance. After that only we can find what is the energy. So these are parallel connections. So we know that C equal to C1 plus C2. We have to add them. So what is this actually? 20 epsilon naught by 4. 20 epsilon naught by 4. This is 28 epsilon naught by 4. I am not changing units. In the end we will change. Okay. So C1 is 20 epsilon naught centimeter square by 4 mm plus 28 epsilon naught centimeter square by 4 mm. So what we got? 28 plus 20, 48. 48 epsilon naught centimeter square. Now centimeter square I am going to write in meter square. 1 centimeter equal to 10 to the power minus 2 meter. So here is centimeter into centimeter. So 10 to the power minus 2 meter into 10 to the power minus 2 meter. 10 to the power minus 4 meter square. Okay. By 4 mm. Mm you have to convert into meter. So 1 mm equal to 10 to the power minus 3 meter. So minus 3. Okay. This 4, this becomes 12. So what we are getting? This will go up 10 to the power minus 4 into 10 to the power 3. So what will come? 10 to the power minus 1. So 12 by 10 epsilon naught. This is C net. Now he is asking energy. Energy is what? Half CV square. C I got and V is given to me as 20. Okay, can we do that? Let's see where we can do that. Okay, then again what I am going to do is I am going to minimize this one more time. Okay, decrease its size. Little more we could have done it. Okay, very good. Okay, right. So now energy. So energy is what? Energy is half CV square. So 1 by 2. What is that? 12 by 10 epsilon naught into V square. V square means 20 square. So 20 into 20. So 2, 10 ja and 10 cancel. What we are getting? 12 into 20, that is 240. Now epsilon naught value we know, no? 8.85 into 10 to the power minus 12. 8.85 into 10 to the power minus 12. Okay. Approximately you can consider this as 9. Approximately we can write its answer. So if it's 9, then 0, 6, 21 into 10 to the power minus 12 joule. Okay, this is our answer. Big question, good question, tough question, slightly difficult to understand. Okay, but I would say it's very good question actually. Okay, nice question. Can I increase its size one more time? Okay, we'll try because it became very small. Increase it, but little bit. Yeah, that's okay. Is it clear, students? Is the question solution clear to you? Okay, good. Right, let's see. I think this was the last question, but let's see. Oh, one more is there. So see then, a capacitor of capacitance 50 picofarad is charged by 100 volt, then connected to an uncharged identical capacitor. Find electrostatic energy loss. Now, electrostatic energy loss, whenever we say, when you are connecting two capacitors, we know its direct formula. We know its direct formula. We derived that energy loss formula. What is that? We said it is half C1 C2 by C1 plus C2 into V1 minus V2 whole square. If you remember this formula, you have to do nothing. Just keep the values. So he says there are two capacitors and both are having same capacitance. One is charged with 100 volt and another one is having no potential. Simple, keep it 1 by 2, 50 into 50 by 50 plus 50 into 100 minus 0 whole square. Okay, but remember that this is in picofarad. Picofarad means 10 to the power minus 12. Remember, okay? Because then normally what happens is we forget. This is also picofarad, here is also picofarad. This is picofarad square, okay? So 1 picofarad and this picofarad is cancelled. So what will happen now? 1 by 2, 50 into 50 means 2500 by 100 into 100 into 100 into picofarad means 10 to the power minus 12. So 100 and 100 gets cancelled. With this 2, this goes 50. 25 into 5, that means 125. 25 into 5 is 125, then 3 zeros. 1, 2, 3 into 10 to the power minus 12. So what is our answer? 1, 2, 3, 4, 5. 1.25 into 10 to the power minus 7 joule or 0.125 microjoule. Okay, one more 10 we release. Micro means 10 to the power minus 6. Pico means 10 to the power minus 12. Okay. Tell me, is it clear? Okay. Neha, is it clear to you? Okay. I guess we have completed. Next is, I don't think anything is there. Yes. So all type of question in these two classes of PYQ 2022 on capacitance we have seen. Okay. So capacitance is over. Okay. Worksheet I am going to post. Solve that one and ask the doubt. Possibly Sunday we will have exam on capacitance. Okay. So that's it for today. Okay. Class notes I am posting on our app. Okay. That's it now. Bye bye. See you tomorrow.